Good morning, everyone. My name is Sofia Cherres, and with my group, Ryan Ranieri, Jose Vigoa, Sophie Pimienta, and Juan de la Cruz, we're going to present our final project, which is reducing congestion at USF with the real-time parking availability through mobile integration.
Hey guys, I'm Hausno Vigoa. So the terms of this project, we analyzed mostly the beer garage, the Collins garage, and the library, to kind of address the problems of having to go around university roads, constantly looking for parking spaces, parking far away from your destination, and just an overall frustration in the parking experience of students and other people who attend the university. So our objective or proposed idea is to create a mobile app that simulates what the Bull Runner app does to give you real-time data on parking availability based on your permit. So you would put in your USF credentials and it would tell you based on your permit type how many parking spots and where you could potentially park.
So our possible solutions or our initial idea was to create a parking lot simulation model, which was considered but was found to be inefficient for the scope of our project because mainly we want to focus on creating a great and effective solution for students. So the primary solution that we came up with was a real-time parking availability app to display open spots by lot and parking and permit type with filters and notifications, which is designed to reduce congestion and search time and easily will integrate into USF systems. So our parking lot analysis was first to observe the peak hour congestions. So we noticed that lots of the lots in the university fill up between 8 a.m. till 10 a.m., causing for students long search times. And also there was a permit specific imbalance, which lead to some permits lots overflow while others are underused. And also there was an inefficient use of space.
Hello everyone, I'm Juan de la Cruz. So moving forward to the survey explanation, to analyze how the US Safe community works, and we implemented this online survey that will help us determine the driver's statistics from which we received around 56 information from different students. This will give us information about how the users move around campus to help us determine several tendencies. Also, the survey will express our possible solutions to the people taking the survey, so we can understand how people will react to our and how the level of acceptance that it will have and the impact it will produce into our society. Moving forward to the results, the first thing that we determine is that most people drive at least 5 times a week to campus, and the vast majority of the population arrives between 8 and 10 a.m., which means that this is actually our peak hour. Also, the lots in front of the and behind the library, the Richard Beard parking garage and the Collins Boulevard garage are the preferred parking locations for most of the students. So the proximity to classes and the availability of spaces inside the buildings are the main reasons for deciding where to park. And finally, the most common problems that students face while parking are the difficulty finding a parking spot in peak hours, lack of real-time information and availability, and parking lots being maxed in capacity. Some of these people prefer to park in less crowded parking lots, which are even farther away from their final destination, meaning they will have to walk more to their classes or their works.
So based on the 56 responses that Wandy had mentioned before, we found that about 70% of those responses stated they would be in favor of an app to give them real-time data, and about 77% of them were in favor of pedestrian overpasses. I think this demonstrates not only the problem that driving a car and finding a spot creates, but also the pedestrians who have to be vigilant of all the cars in those peak hour factors and trying to find their way through traffic while they're also trying to get to their destination. Also, from the survey, we found that 43% of people did not want to have a reservation-based parking system. So 43% of people felt like reserving a parking spot did not accommodate them or was not of interest to them for whatever reason. And so we think that that would not probably be something integrated in the application itself.
Hello, this is Sophie. And based on the result of the survey and the analysis of the parking issues identified, we propose a dynamic parking management system as part of an intelligent transportation system strategy. The system collects real-time data from infrastructure installed in the parking lots and channels it into a mobile application, allowing users to make informed parking decisions according to the permit type. The system consists of 4 main points: sensors or license plate recognition cameras, a server that processes occupancy data in real time, a graphical user interface for the end user, and an API that validates access according to the permits issued by USF Parking Services. And using predictive routing algorithms, the system guides drivers toward nearby lots with real availability, also minimizing on-campus travel time and reducing emissions and bottlenecks at internal conflicted points. The mobile app will include an improved interactive map built on the state campus that layout that users, students, and staff are already familiar with. It will show real-time availability of parking spaces using live data from sensors and GPS, so users can quickly see which lots have open spaces and filter them by the permit type. Users will be able to set their preferred slots and get alerts when spaces open up in those areas, saving them from circling around. Also, it will have a smart notification system that uses past data to suggest the best time to find a spot, and even give turn-by-turn directions to the nearest available spaces. The interface will maintain USF branded and follow the University Digital Accessibility Standards. Notice that the deployment of this app will be staged. Right now, we have already started with the gathering feedback from the students on the survey. And the pilot phase of the app will focus more on the most crowded and frequently used student parking spaces. From there, the solution will continue to expand based on how well the system works and what we learn along the way.
My name is Ryan, and our systems, proposed systems that is, offers a range of benefits for the USF community. First off, it significantly improves efficiency by helping users quickly find available parking, which reduces the time spent circling lots. That would in turn help reduce congestion on campus, since fewer vehicles will be aimlessly driving around looking for an open spot to park. The app also encourages better permit compliance by guiding users to lots where they're actually allowed to park. This would make parking much more fair and balanced. And on the environmental side, less idling and circling means fewer emissions and lower fuel usage. And of course, user convenience is key. So the live updates, filters, and notifications within our application would all work together to make the parking process much smoother. Plus, the system's data tracking will give USF valuable insights for ongoing planning and improvements in the future. At the end of the day, USF's parking issues are more than just a constant inconvenience for students and faculty. They impact overall campus mobility, equity, and sustainability. Our solution combines smart technologies with community input to create a real-time, user-friendly system that addresses these challenges directly. By improving efficiency, reducing frustration, and supporting smarter infrastructure decisions, we believe that this projected project has the potential to truly transform the parking experience here at USF.
Thank you.
Thank you.
Thank you.
Thank you.